Also reporting now from some of the outer reaches of the world, there is new research from both poles of the Earth that indicates an even greater sea level rise than was expected just 2 years ago. That word is according to the Clean Air, Cool Planet group. This climate education coalition has a pair of scientists here in Washington today telling lawmakers what they saw during their recent research trips to Greenland and to Antarctica. Now, the group is predicting that climate change will bring as much as a 3-foot rise in sea levels by the end of the century. That's about a foot more than the IPCC's projection back in 2007. And Clean Air, Cool Planet says this is what the Chesapeake Bay area will eventually look like as a result. You see those light blue areas growing? That is where researchers say sea levels will rise, an especially troubling analysis for the Delaware, Maryland, and Virginia coastlines. And today, we are getting a first-hand perspective on the effects of climate change. Joining us now to talk more in depth about this report is Gordon Hamiliton. He's a professor of climate science at the University of Maine. He's also a contributor to the Clean Air, Cool Planet report and is now back from his studies in Greenland. Gordon, it's great to have you with us today.
Great to be here.
Let's talk about what you saw in Greenland. I know one of your colleagues went to Antarctica. Specifically, you went to one of the theoretically colder places on the planet, and you had an interesting quote about icebergs, as you said, being calved off the ice sheet at a rate 3 times faster than just a few years ago.
Exactly. So we're looking at the parts of the ice sheet that come into contact with the ocean. And in just the last few years, since basically the summer of 2003, we've seen a lot of these glaciers suddenly speed up. And we think of them as conveyor belts. And they're moving mass from the middle of the ice sheet down through the valleys. And then when they get to the ocean, they discharge icebergs. Because the glaciers are speeding up, that means they're discharging icebergs at a much faster rate. But the rate of increase has really caught us by surprise. So it's doubled and tripled for a lot of the big glaciers in Greenland in just the last 5 years.
There's a pretty decent discrepancy, Gordon, between your new estimate and what the IPCC said back in 2007. At that point, the conference was predicting at most about 2 feet of sea level rise. You're talking about 3 feet and change right now, and that's just a 2-year change in estimate.
Yeah, well, the IPCC report was based on science that was done and in the public domain by the summer of 2005, although the report didn't actually come out until 2007. So there's a little bit of inertia in the way that the IPCC process works. The curious thing started to happen in Greenland around about the time that the science was being finalized for inclusion in the IPCC report. So the kinds of changes that we've been observing in the last few years in Greenland and also in Antarctica, although, of course, the IPCC authors are well aware of these events taking place, they're not quantified and understood in a manner that was reliable enough to be included in the IPCC estimate. So, as you say, the report came out with a range of sea level rise by 2100 of, we speak in metric, so it's 18 centimeters to 59 centimeters, which, as you say, is around about 2 feet.
Focusing on Greenland for just a second, Gordon, that's not very close to home for virtually anyone who's watching this broadcast.
No, that's a question we get a lot. Why should we be, as taxpayers, sending scientists to Greenland? But the reason that we go to Greenland is because we have all this mass stored on the continent of Greenland in solid form, and if we melt that and put that into the ocean, then we're going to raise sea levels. And because the world's oceans are connected, it doesn't matter where we add that extra mass or water to the ocean, it has an effect globally. So what happens in Greenland and what happens in Antarctica is going to hit very close to home in the coming decades.
And this report is pointing out specifically the effects on the Chesapeake Bay region, the nation's largest estuary. Major cities involved in here, Washington, D.C., Baltimore as well. And as we see the graphics that your team put together on the estimated sea level rise, this is pretty instructive on exactly what 3 feet of water level rise can mean.
It does. It means a lot of, well, ultimately it means a lot of permanent inundation of land. And being the nation's capital, there's a lot of infrastructure and a lot of commercial value held up in that land that's going to be flooded. Of course, before the permanent inundation happens, we're going to see things like storm surges building on an already heightened sea level. So the damage and destruction from storm surges, or the convergence of storm surges and heavy rain runoff events, they're going to bring this whole issue of sea level rise and the impacts close to home very soon. And by very soon, we mean in just the next decade or so.
In terms of recommendations from your report, one issue is improving infrastructure. How do you prepare for what you see as such a dramatic change?
Well, it's difficult to engineer against a sea level rise of 1 meter or 3.3 feet, because if you think about where the population is distributed around the world, is clustered in the coastal zone. That's where cities and towns have traditionally grown up because of the trade routes and the resources of the ocean. So with so many people close to sea level, it's hard to engineer against a sea level rise of 3 feet and protect everybody. Mm-hmm. Of course, the Dutch are doing it with dams and dikes, but they won't hold back that ocean forever. So I think the best thing to do is actually to get ahead of the problem and put us in a situation where we won't generate that 1 meter or 3 feet of sea level rise. And
that is essentially capping carbon emissions. And
yeah,
that brings
because
us to
the changes we see in Greenland and Antarctica are the ice sheets responding to a warming of climate. Mm-hmm. And we know from the work done by thousands of scientists around the world that the climate is warming because of our emission of greenhouse gases into the atmosphere.
And that
so
brings
it's
us
easy to make the connection that you reduce the greenhouse gas emissions, that will reduce the rate of warming and will reduce the severity of the changes that we're seeing in Greenland and Antarctica.
Which is why you're here in Washington in the first place, Gordon. That is getting lawmakers to pay attention to some of these effects. What reception do you expect when you visit Capitol Hill to talk about potential climate legislation?
Well, it's difficult to, of course, legislators are balancing a whole host of issues that are important to them and their constituents. But I think it's instructive for me, for one, to be invited here in the first place. And it shows me that, legislators are interested in keeping up to date with the most recent science. They're not just looking at the IPCC report, which is a great document, but as I say, it's 2 years old. That they are interested in finding out what, scientists are learning, right up to the present day, so that they can make the most informed decisions going forward.
Gordon Hamiliton is a professor at the University of Maine, where he teaches climate sciences and also is a contributor to the Clean Air, Cool Planet report. Gordon, thanks for being with us today.
Glad to be here.